uniform. There's the right uniform.
Hang on.
Are you done with them?
Not the quiz corrections.
Oh, yeah, just lay it on my keyboard. Wow. Okay. I finally got to where I need to be.
Is your technology going to work on Thursday?
It might. But I'm going to do this. I'm going to move this thing, and then it's going to pop off again. All right. There we go. So, acid-base reactions. Finally got to where we can actually do something here. And hopefully my ink settings stuck because they reset everything on that. Hopefully I can still write on here now. Okay. Pull up my sleeves and let's get going. So we talked yesterday briefly about acids and bases. And we said with acids and bases that we are donating these protons. Okay. So hydrogen is just moving. And what you're going to do with these when you're trying to identify them is you are going to look at them and then you are going to find the pairs. So which things are similar. And then from those pairs, you're going to find the one with more hydrogen. And that's your acid. The other one's your base. Okay, remember that? Okay. That is the definition, or that's the way you do Bronsted-Lowry bases. Okay? Again, like I said yesterday, there are Lewis acids and bases definitions using Lewis structures to be able to determine them. When you get into college, you will most likely encounter those. So there are other definitions of these. There's an older one that says that one produces hydroxide ions and one produces hydrogen ions. We don't use that one anymore because it doesn't always work. Yep. I didn't fill yours out, so you're going to have to fill your own out. I'm sorry. You kind of blended in back there. I didn't notice. Okay, so we talked about these yesterday and how we're just simply looking for that hydrogen moving back and forth. Okay, the stuff on this side, then you're going to find the pairs. So you can see how these green ones match up here. Okay, and that then is going to have more hydrogen. So this is your acid, this is your base, and we indicate that we're on this side of the reaction by using the word conjugate. Okay. Over here, you can see that we have these two are similar. This one has more hydrogen, so that's going to be your acid. This A is just a placeholder for a negative ion. So this could be HCl, it could be HF, it could be HI. Any negative ion, the ion's going to be left behind as an ion then over here. Okay? Over here, you've got your base and your conjugate base, or conjugate acid over here. So you have your base, and then over here it's going to be a positive because you're adding a hydrogen to it. This hydrogen is going to drop off the water. Remember, water can be written as HOH. So here's your HOH and your OH. See how they're related. Okay? Has more hydrogen. Loses a hydrogen. Gives it over to here. Okay? So acids and bases. We talked a little bit yesterday, too, about the strength and what that means. If you have an acid such as HCl, you put that into water, that hydrogen from the chlorine is going to get donated to one of the water molecules, leaving the chlorine ion behind. Most, if not all of this is going to form into this material. We indicate that with a forward arrow. Down here, this is acetic acid. acetic acid is a weak acid, and I'm going to show you how you know if they're strong or weak just from a listing in a minute. Okay. This is a weak acid, so we're going to use a double arrow here. Now, when you're drawing these, it's hard in these places. A lot of times people will draw them like that, or you will sometimes see them drawn like this. This is a much faster way of doing it. So that's why when you're actually doing it yourself, most people go with this top option here that I drew, because that is just faster. One, you don't have to lift your pen. You just, you're done. Okay? Here, you're having to lift your pen 4 times to get that to happen. So, right? Do. So, this is faster. 1 pen stroke, 4 pen strokes. Okay? All right. So, it is important to note, and this is something you're just going to have to kind of bring in and memorize. Stronger acid will form a weaker conjugate base. A weaker acid will form a stronger conjugate base. You pretty much just have to kind of bring this in and own it. Okay, stronger base, weaker conjugate. Weaker base, stronger conjugate acid. The conjugate of a strong acid or base has no acidic or basic properties. Okay, so if you have your HCl, let's just take that. We put that into water. Single arrow. This is a strong acid. You're going to know why in a minute. Well, you know why it is, because it's 100% ionizing. Okay, but you'll know the list in a second. That's going to form H3O plus. Instead of H3O plus, people typically write this as H plus. Do whatever you need to do. Okay. If you can't recognize that that is the same as this, then write all of this out. Okay. They don't care. It's just a shorthand method of doing it. Okay. And then this is going to give off your chlorine ion. Okay. That's what happens when it is a strong acid or base. So it's going to form all of these hydrogen or hydronium ions is what they're called. Okay. And when you are measuring for acidity, this is what you're measuring. This is what your pH meters are measuring. Okay, they're measuring how many of those you've got present. Because that's how you determine pH, is the concentration of those hydronium ions. If you have more hydronium ions than you have OH ions present in your solution, that is what an acid is. That is the definition of an acid. Chase? No? Trying to figure out how to ask the question, or?
I don't know. No, I guess I could.
Good. This is just honestly like something that you're going to have to like take and internalize. Like spend some time internalizing that. Bring that in, make it your own, figure out some sort of memorization technique to get that kind of brought in and own it.
If the H3O plus is the same as H plus, what happened to the oxygen?
It like I said, it is H plus is this. It's the same thing. People just use this as a shorthand instead of writing this out. They're just abbreviating it.
Please excuse this interruption. This is Mrs. Pamilia. Staff and students, there are issues with the Wi-Fi networks. A team of IT are working on it. Please use BYOD, bring your own device, when you can, or use the guest network. If you use the guest network, you will be prompted regularly to rejoin the network, which is okay, but try to use BYOD as much as possible until you hear another announcement or you or staff get an email from IT. Thank you.
Libby, tell me how you feel on this Tuesday.
It's a Thursday.
Join the BYOD
Happy
network
Thursday,
where at all
Libby.
possible.
All right. So, like I was saying, this and this are the same thing. Okay? People use this as an abbreviation. Okay? This equals this. So, if you can't resolve in your brain that this is the same thing as this, write this out.
Why are they the same thing?
Because that's the way people have determined that they're going to.
Just for H3O, or is this for like
Yes.
all?
Nope. Just H3O plus can be represented with an H plus. Okay? So then don't write this out. Don't write this out, Maddie. Like straight up. Like just get rid of that.
But an
Okay.
oxygen with 3 hydrogens is not the same as just one hydrogen.
But I'm telling you, that's the way it is. You're going to see this throughout. You're going to see it all the time. Get used to it.
Darn it, they make things confusing.
Yep. Welcome to chemistry. All right. So here is your memorization. Okay. You have to memorize these strong acids and strong bases. Okay. There are acronyms out there. Go out onto Google and Google some of them. Find one that works for you for the strong acids. The strong bases are easy. Okay, let me show you the strong bases. It is the first 4 alkali metals on your periodic table, and then calcium down to barium. So if you just take your periodic table and let that be your guide for the bases, then those are easy. Okay? So just think of this as your periodic table, and then those are pretty easy. These are the ones that are a little bit more difficult to kind of internalize. But if you kind of go out onto Google, there's plenty of things out there that you can find, acronyms and different ways, different memorization techniques that you can use. Okay. Now, these 3 on the strong acids are fairly related. So if you can just go, yep, if it has chlorine, probably there. All right. And then this one, and then your chlorine, of course, all of these are halogens. So they're in the same family. Okay. So that really just leaves you with nitric, the first hydrogen of sulfuric. Okay. and then these. And so it's really not that bad. Now, if it's not on this list as a strong acid, it's weak. So any acid that's not on this list is weak. So if you memorize these acids, then you don't have to memorize all the weak acids because everything that's not on here is weak. For bases, same idea. If it's not on this list, then it's a weak base. So if it's a base and it's not on this list, it's weak. There is a difference between a strong acid, strong base, and a dilute or concentrated acid or base. Okay? So HCl is always going to be a strong acid. But if you have like 0.00001 molarity, that's going to be very dilute, right? Okay? So very little. So this is going to be a dilute strong acid. People want to think of strong acids and strong bases as being concentrated. Oh my God, it's harmful. It really depends on the concentration because you can have a weak base or a weak acid that is concentrated and it can do a lot of damage. For example, hydrogen fluoride or hydrofluoric acid. This will actually, if you get this on your skin, it will actually leach calcium out of your bones and they have to amputate. We don't have any of this at school. You don't have to worry. But that, it's a weak acid. By definition, it's a weak acid, but it can do some serious damage. Okay?
What is that used for?
I don't know.
I don't think they use it.
Like there's not many practical uses.
Doesn't it like turn your bones to stone? Something like that.
It leaches the calcium out. They literally have to amputate for it. It's some scary stuff.
I think I just like at that point.
Oh, here we go.
Oh,
So it looks like they do use it some in industry, but little scary stuff. I'm just telling you, like that's some scary stuff. It's bad, bad news.
is
Okay.
it so diluted that it won't like harm you too much?
I don't know. It's just some scary stuff. Just don't want them around it. We don't use it here, so you are just fine here.
We just show up. We're like, oh, hey, so matching today.
Get the fuck out.
All right.
I know which one of my books are I didn't know.
So we are going to, this is an acid-base reaction here. We are going to identify our acid bases and the conjugates. So I find my pairs. First of all, is number one in acid-base reaction?
No,
No, there's no hydrogen to
make it an acid.
make an acid base. So that's gone. Okay, this guy here. Are we exchanging hydrogens here? Okay, so that guy's out. Down here,
Light down.
Yes.
who's it donating it to?
It's
It's a synthesis reaction, so it's not getting donated here. All right, so that leaves this guy. So he must be our acid base if we had to figure out which one it was, okay? So where are my pairs? I've got a pair here and a pair here, yes? Everybody good with that? Which one has more hydrogen? He's being a brat. So this is my acid. This is going to be my base. Then I have this guy and this guy as a pair. This one has more acid or more hydrogen, so that's my acid. This is my base. How do I distinguish this side? I call these conjugates. All right, identify two acid-base conjugate pairs. You guys should be able to do that. Do that one, and then we'll talk about two. Is this a different equation? Am I just not reading this right? Okay, nitrate is a stronger base. So this is stronger. And that means that this is weaker. That means that this is weaker. No, stronger base than this. So this is weaker. There we go. Oh yeah, that makes sense. Okay. So then that means that this is going to be stronger. And this will be weaker. And I'm going to explain to you why in just a second, okay? Okay, you ready? No. This is like, I gotta like get myself.
Mentally.
Yeah.
Yeah. I'm right there with you, love.
I need to make sure everybody's done writing so they can listen. So that's why I'm pausing. Good? Everybody ready? Okay, so the difference between a stronger thing and a weaker thing is that the stronger thing is going to break apart and stay as ions. The weaker thing stays together more. Very little of this H plus right here is going to break apart and form into this. So the stronger the acid or base, these things, the more they break into these things. Remember, this reaction is going back and forth and back and forth, but most of the stuff is staying in this form on the weak side. Most of the stuff is staying like this.
How do we know it was going back and forth just from like
That arrow.
But the arrow wasn't in the question. Like, is it because we know that?
So anytime that you have things that are not strong acids or bases, this was not on the list, you have to use these back and forth arrows. The only time you use a straight arrow like this going in one direction is if you have one of those acids or bases
On the reactants?
on the reactant side. Okay? That's why you have to memorize that list. Because if this doesn't appear on that list, you're using that arrow. And honestly, guys, even when you have a strong, oh, I lost my stuff. Shoot. Even when you have a strong acid, you're still having, so most of the material, almost all of it, let's say 99.9% of your material is here. You still have, and we'll get into the math of this later this year. Okay, I'm just throwing out some numbers now to kind of give you an idea. This is still going back and forth, okay? But most of the stuff is staying over here. This is called dynamic equilibrium, where this stuff is forming into this stuff, and this stuff is reforming. But most of the stuff is staying over here when you have a strong acid or base. But with these acid-base reactions, a little bit of it is still popping over to here. But then that stuff won't stay. It's going to pop back to here. But a little bit of this stuff will pop back over. And that's called dynamic equilibrium. So it's just kind of going with the flow. But most of it's staying over here. Now, when you have a weak, most of it stays over here. Presley?
That's my question.
Okay. Maddie?
Is it kind of like when there's a dipole? If this one's really strong and this one's not so strong, a lot of the things are going to stay over there.
Yeah.
But how do we know like which one's strong? Like
You have to memorize the list.
where the other, but like the problem or something. Like
The acids
yeah.
that were listed, none of them were on this list.
Okay.
So it's weak. The bases, none of them were on this list. So they're weak.
Okay, but how do we know that they're stronger? Like
Because they told us in the problem. They said this is the stronger base.
oh.
So I read the problem.
Flip, you have a question.
But if they don't tell you, you don't know.
So,
Or if they don't give you numbers, you'll eventually get numbers for this when we get into Unit 8. But right now, they would have to tell you.
So you know that from NO2 it's a stronger base, so then there's a weaker acid. But how did you know that HNO2 is weaker?
Because if this side of the reaction is favored, right? This one has, if this is forming over to here, then this is also got to be forming over here.
So it's always like the same on both sides?
Yeah.
Okay. Okay.
So if you can figure out one, you got the other one nailed.
okay. That answers
That's
my
what I was
question.
about to ask. It told you stronger base, so wouldn't that just automatically mean weaker acid on the other side?
What if I got, so I would never get like a strong acid on the reacting side and a weak base? They'd both be strong? Well, not when you get like farther in the line, but like right now, like on the AP test, where I
Right,
see
yeah,
like
right
a
now-
strong and a weak.
Right now, you should be fine.
Okay.
But eventually we're
Later
gonna.
down the line.
Yep.
Okay.
That's a future me problem.
Yep.
Because you love me. There we go. I finally